relationships and graphs. So we kind of talked about this the other day, but you need to know the difference between a direct relationship and an indirect relationship. A direct relationship is when one variable increases, the other variable is also going to increase. So in terms of density, as the volume increases, the mass will increase as long as it is the same object. So that's a direct relationship. An inverse or indirect relationship, so you're also going to hear both terms, inverse or indirect. This is when one variable increases, the other one is going to decrease. So with density, as temperature increases, the density will decrease. We talked about this with density the other day. Okay. Now a constant relationship means as one thing increases, the other one stays the same. This is in terms of, well, they're talking about temperature and time, that as time goes on, the temperature is going to stay the same. This is what happens or what should happen in your refrigerator if you were never to open it. Hopefully. Okay. Now, with the rate of change on graphs, so when you see a steep line, that means that the rate of change is going to be quick. Whereas when you see a gradual line, that rate of change is a little bit less severe. It's going to be at a slower rate that something is going to change. So now we have things that are cyclic. Cyclic things are going to show up a lot in earth science, so you need to remember what it means. And it's that changes in the environment occur in some orderly fashion, which events are constantly repeated. There are a lot of events in earth science that are cyclic, that it happens and then it doesn't happen for a while. And it happens, but you can predict when it's going to happen. That's why it says predictable time intervals. So, for example, sunspots are very predictable. They usually happen every 11 years or so. They're predictable to some extent of how intense they're going to be, but that's not, because as you can see, they're kind of all over the place, but you know that they're going to peak about every 11 years. Another thing that's predictable are tides. And when the high tide comes in and the low tide goes out, they know that they come every about 12 and a half to 13 hours of when it can shift. So that's why the high tides and low tides are different day to day, but you can predict when they're going to come in and when the tides are going to go out. Another thing is the sunrise and sunset. You know generally what time the sun is going to rise and what time it's going to set as the days goes on, depending on what time of year it is. So that's predictable throughout the entire year, and it's cyclic because it's the same thing every single year. It doesn't change drastically enough. So other things that are cyclic that we hadn't talked about are moon phases. Moon phases are cyclic in that every month the moon has a full moon and a new moon, and it kind of goes through its phases. Tides, we said, Earth's revolution. So the fact that we have years, that's also cyclic. Lunar and solar eclipses, those are cyclic, but they're harder to remember. It's not something you need to memorize. We talked about sunspots and seasons. Things that are not cyclic, things that you can't predict when they're going to happen on the basis of time, is weather. Climate is different. Climate is different because that's cyclic in terms of seasons that deals with, but weather is going to be non-cyclic. Earthquakes, you cannot predict when they're going to happen and how intense they're going to be, nothing like that. Landslides are non-cyclic. You don't know when a landslide is going to happen. And meteorites, obviously. There's times that we get close in terms of meteorites going to possibly, but it's not cyclic enough to know that, gee, on this day, it's going to come into our atmosphere and burn up, etc. Okay, so why is it important to be able to predict events? Well, it's important because sometimes some of these events, especially like tides coming in and going out, can be dangerous during certain times, like if you have a large ship and that ship needs to go out during low tide because it's too shallow in the area where it is. Different things that will prevent injury of people or death or property damage, so on and so forth. So on a sheet of paper, you can practice some of these on your own that we already went through. Keep going to the next one. So moving on farther into your notes, natural hazards and disasters. We're going to talk about this a little bit. A non-human related object is a natural hazard. Process or situation that has possibility of causing loss of life, personal injury, or loss of property. Landslides, hurricanes, tornadoes, earthquakes, all of those things are natural disasters, natural hazards. So I just gave you some. Hurricanes, floods, earthquakes, thunderstorms, tornadoes, tsunamis, and volcanic eruptions. Remember, tsunamis are not weather related. They do not have anything to do with the weather. It's caused by an earthquake. So are all natural hazards predictable? No. Do you know exactly when they're going to happen? No. Do we have warnings about them? Yes. There are times that they can predict about tsunamis, where they're going to hit once the earth shakes. You can tell when the wave could be coming in. With tornadoes, you have a warning if they're going to possibly be in your area, but there's no way to predict it, specific location and time and all that stuff. Are all natural hazards cyclic? We already said no. So why is it important to make predictions on the ones that we can? This can save lives. If you can predict that there's a hurricane coming, you can tell people, hey, hurricane's coming in a day or two. Why don't you get your stuff and get out of here, because there's going to be significant flooding. If you choose to stay at your home, that's your own decision. But a lot of times they have mandated evacuations that you have to leave, and that's to save people's lives so that other rescuers don't have to go in and save you because you decided to stay and not follow the rules. Because we don't want to put people who are rescuing us, their lives in danger any more than what we have to. So, answer the following questions. I want you to name 2 events that are predictable, 2 events that are cyclic, and 2 events that are non-cyclic. You can go back through your notes and do that. So, energy. Change involves a flow of energy from one part of the environment to another. So when something loses their energy, something else is going to gain it, because that's the transfer of energy. That's how it works. So for example, when you have an earthquake, energy is stored in the rocks and then it is lost and it's converted to sound, heat, and shaking of the Earth's surface. So that's how energy can be moved. Where is it exchanged? It's called an interface. This is the boundary where energy is transferred, or a boundary between regions with different properties. You actually travel through interfaces when you walk in and out of a store sometimes in the summertime. You know when there's that blower that blows on you when you walk into a building. Sometimes it turns on when you walk in and then it turns off after the doors close behind you. That's called an air curtain. That actually helps the air from the inside not flow outside, or vice versa. So what those air curtains do is it kind of keeps the air conditioning on the inside and the heat on the outside, or it keeps the heat in the building and it keeps the cold air from coming in the building. So interfaces exist between different layers of the atmosphere. That's where we also can have them. Environmental equilibrium. This is where the Earth wants to naturally balance itself out. And it will do that through its environments by constantly changing things to kind of get it to balance out. So a lake may look different season to season, but looks the same every fall. So what it's trying to do is when the leaves come into it and things break down and all of that happy stuff, it's trying to balance itself out. So is most change a large scale or small? Most of it's on a small scale, but when it is on a large scale, it usually has to do with some kind of large natural hazard of some sort. So dynamic equilibrium is when environmental equilibrium resulting from opposing forces or actions balances out. Are we ever in that dynamic equilibrium? No, it's hard to get there, but the Earth is trying to all the time. So that's why the level of the lake remains the same, even though thousands of liters of water move in and out of it every day. So energy flows from high to low. You're going to have to learn that. I will have you repeat that on different days. And natural resources. These are materials and energy that sources are found in the environment that humans use in their daily lives. You use natural resources all the time and you don't realize it. So some natural resources is air you breathe, the water you drink, plants and animals used for food or clothing, energy from the sun, you have fossil fuels, there's rocks and mineral resources. The device you're using right now had stuff that came out of the ground and is now put into your device. All of the plastics, all of the metals, all of that came from the earth somehow. All right? So what's the problem with natural resources? There are some places that there's conflict over supply and ownership. Who gets it, who gets to keep it, especially the things that you can get out of the ocean, because some of the oceans, it's like, where's your property line kind of thing. There's also a shortage. We're eventually going to run out of stuff, and there should be substitutes for other materials, or the fact that we should be able to recycle things. Recycling is a good thing. You want to recycle because we're reusing natural resources where we don't have to pull more out of the ground in order to get more of what we need. Because when we do use stuff and you just don't reuse it or recycle it, it becomes pollution of some sort. So this occurs when the concentration of substances or forms of energy reaches a proportion that adversely affects people, their property, and other life forms. So think, there's pollution in Cambridge, there's pollution in Stillwater, there's pollution everywhere. It just depends on how much, and where you live depends on how much, because obviously the closer you get to New York City, there's more and more people there. You're going to have a higher amount of pollution. We're up here in lovely Stillwater, there's a lot less people, so there's a little bit less pollution in the area. Less cars. So causes of pollution, technology. Unfortunately, all the wonderful technology that we have does produce quite a bit of pollution. Natural events or processes, things that we don't cause, like pollen, volcanic ash from wildfires from out west, that causes air pollution, and gases from volcanic eruptions, x-rays from uranium, radon in rocks and soils. Some people have to have radon tests in their homes because you can get radon poisoning from that. Okay, so pollutants are substances and forms of energy that pollute, including solids, liquids, gases, biologic organisms, and forms of energy such as heat. Heat can be a pollutant. Sounds can be a pollutant. Visible light can be a pollutant. And obviously nuclear radiation is pollution. But you can have heat pollution where it's pumping out heat outside. If you were heating up your car in the wintertime and you roll all your windows down because you're too hot, you're actually putting heat pollutants into the air because air's supposed to be cold in the wintertime. Another thing with sound pollution, factories put out a lot of sound pollution. That if you lived near a factory and you could hear it and it's not perfectly quiet, that adds to sound pollution. There is light pollution in cities and towns and whatnot that shines up into the air or shines up into the sky, and you can't see the stars as well because there's too much light pollution. So pollution is not just garbage outside that you can see on the side of the road. There's all different kinds of pollution. So what kinds of environments have a lot of pollution and why? In your cities, you're going to have a lot. And the more people you have, the more pollution you're going to have because there's so much stuff that they're using in garbage and all of those things. So the greatest along the Hudson River, is it Schuylerville, New York, or New York City? Where do you think has the most pollution? Obviously, I was just talking about it, so it's probably going to be down in this area, down towards New York City. Why? Way more amounts of people. Which city would have a higher concentration of air pollution? We already said it would be New York City. Okay? Those are the graphs, and there was extra stuff included in there, but it fills out your notepad.